Thanks everyone for joining in. So I'm Simran, developer advocate at OpenObserve, and we have with us Chaitanya, who is solutions architect. And today we'll be diving into distributed tracing and auto instrumentation with OpenTelemetry. So before getting started, let me quickly walk you through today's agenda. So we'll start with the basics, what are traces and spans, and then we'll talk about how tracing is important for modern systems. We'll talk about how to collect tracing related data using manual instrumentation, what are the limitations associated with manual instrumentation, and then we'll talk about OpenTelemetry auto instrumentation. Post that, we'll have a demo around instrumenting different services with running with under different languages, and post that, we'll have a Q&A. So feel free to drop in your questions during the session. You can make use of the Q&A feature in Zoom. And yeah, let's get started. So think of any request coming into your system, be it a user logging in, an API call, or even a checkout request. So any request which comes in doesn't stay at a single place. They jump across multiple different services. So there is API layer, there is authentication layer, or there is maybe even an external API call. So a trace is basically the entire journey of a request, and a span, that is a single operation within that journey. So a span can be a database query or an internal function which is processing a request. So when you pull all the spans together, you get the full trace. Now, what makes this so powerful is the type of questions it helps us in answering. So with these traces and span, you get answers to common issues like where did the request slow down, or which dependency is causing the errors, or what is leading to retries, or in basic, like what exactly is contributing to the user facing latency. So with that, we understand like what are traces, what are spans, and like why tracing is important in modern system. Now the next question is, how do we collect this tracing related data? And that's where OpenTelemetry helps. So OpenTelemetry is the industry standard for collecting all the telemetry data, be it logs, traces, metrics, everything. And it basically gives you a vendor neutral, a consistent API for instrumenting your applications and collecting the data, no matter where you are running your services or which language you are using. And here's the best part, you don't even need to figure out your own way or invent your own way to design the tracing logic. It basically provides you with a tracer, context propagation, and the exporter so that you can collect the data and send it to any backend services, including OpenObserve. So here is a quick snapshot of what instrumenting your application might look like. So you basically make use of the trace from OpenTelemetry library and a single function that start as current span that basically creates a span. And what OpenTelemetry does is it collects all the different spans and it stitches them together, so you get the entire trace view. You get timing, you get context, you get the parent child relationship, everything which is needed to understand the end to end request flow. But here's the catch, as your system grows, this manually instrumenting everything becomes very painful. So I'd like to understand what currently you are using to get the tracing data. Raven, can you bring up the poll? Yeah, feel free to drop in your what kind of instrumentation you are currently having, be it manual, auto instrumentation, anything. Yeah, we'll wait for a minute or two to get the responses. Yeah, I hope everyone has answered the poll by now. Raven, can you show? Okay. So around 40% of you are already using auto instrumentation, but 25% are still using manual instrumentation, and 25% a mix of both. Okay, great. We'll cover what are the pain points associated with manual instrumentation and then hop on to how the auto instrumentation is helpful. So basically, when your system grows, your services is not limited to a single service. You have multiple services running. You have microservices based architecture, and those all those services might not be written in a single language. Some of the services might be written on top of Java, some in Python. So, a number of languages can be used, and on top of that, all those microservices might not be running in same environment. Some might be running in a virtual machine, some in containerized environment, or some even in serverless environments. So whenever a user request comes through, they'll have to run across different microservices, different message queues, database, cache, external API, a number of stuffs plus the network hops along the way. So manual instrumentation slows down the entire process. So it basically, when you manually instrument your code, you have to add spans manually to every endpoint, every database call, every external request. That adds to a lot of boilerplate. And given you are doing things manually, it's often easy to forget and to mess up. You can miss critical parts, and what you end up with is like broken pieces. You don't get context on what is the root cause of the any issue because the data is incomplete. And also, as your system, as you add new features to your applications, you need to add instrumentation code everywhere. Like every time a new feature gets pushed in, you need to add instrumentation codes as well. So that adds to operational overhead. Now that's the point where most of the teams end up saying there has to be a better way, and that better way is auto instrumentation. So we'll do a quick comparison around manual versus auto instrumentation. And as the name suggests, given things are being done manually, for setting up manual instrumentation, that is a high effort task. And when it comes to auto instrumentation, the setup task is like almost negligible. We'll see how this turns down to a very minimal zero effort thing when it comes to setting things up. But yeah, it's almost zero effort task. Then, when it comes to coverage under manual instrumentation, it depends upon the developer where they're adding the pieces of code, what part is getting generating the spans, what part is adding to the traces. But when it comes to auto instrumentation, each service of yours, each function inside those services is getting full coverage. And when it comes to consistency, under manual instrumentation, it varies from developer to developer. But when it comes to auto instrumentation, things are standardized, they are in consistent way. Again, the same thing. And when we have multiple services running in different languages, manual instrumentation is quite time consuming process. It's difficult. You have to do stuffs manually. With instrumentation, things get a lot easier. So how this auto instrumentation works is it basically bundles all the OpenTelemetry SDKs, the instrumentation libraries, and the exporters all into a zero code bundle, and you can inject that bundle into your application simply by adding annotation. Okay, I'll hand over to Chaitanya and he'll walk us through what will be auto instrumenting today.
Awesome. Thank you so much, Simran. Hey guys, this is Chaitanya, Solutions Architect at OpenObserve. And we will focus on auto-instrumenting a hot commerce application. As part of a demo, we will walk you through what services, and it's a distributed framework. As you can see, front end with Go, and Node.js for shop, and for product is Java, for review and price, Python and .NET, vice versa. Can you go to the next slide, Simran? So over here, we are annotating each service with OpenTelemetry, right? What we are doing is we have a deployment file, which right now we require a Kubernetes to actually run this services. And we are expecting Kubernetes to be present and OpenObserve for all the tracing and five services that we'll be deploying. So let me quickly share my screen and walk you through the demo. Okay, cool. So this is a hot commerce application that we will go ahead and deploy. And this is public. You can simply go to OpenObserve and Hot Commerce, and you will be able to see this repository. And for this one, we already have a Kubernetes cluster that is running, and we will be deploying the services in our cluster. So if you simply go to the deployment.yaml, you will see each service that is having annotation to be instrumented. And we just single line, this one line, we are actually getting all the traces propagation from services to OpenObserve. Now, I've already deployed the services. There you go. I've already deployed the services, and all I have to do is apply my deployment file. And once we have applied our deployment file, we'll quickly port forward. And we should see this service is running. Let's see, I think, yeah, 1001 port. And you should be able to access the URL. We have a sample response, and this is a sample product. It's a hot commerce application, so you'll see end-to-end how it actually works. Now, I will go ahead and generate some data. So I'll click on few reloads. I'll go ahead and change the item to 12, and maybe let's make it 1, 2, 3. And now we have generated some data. Now, in OpenObserve, we have the traces dashboard. So you quickly go to traces and switch to the default. And the service name we are expecting to be the front end. So let's filter out all the services that is matching front end. And you'll see 12 traces that got generated in the last 15 minutes. I'll run the query once again, and then we have all the 12 traces. So if I quickly open one of the traces here, you will see all the spans part of this transaction that is happening from front end all the way to shop. And if I click on one of the spans, for example, let's take a review, you will see the tags, the process, and also the attributes that are associated with this specific trace ID. Now, what we'll do is quickly go ahead and generate some more data. So let's simply, I'm using Apache benchmark here, and I'm actually hitting about 10,000 requests with 10 concurrent users, which will be 1,000 per request. So let's quickly trigger that and get back here and start running the query. Shortly, you'll see a lot of traces coming in. We got 25 traces. This will keep on increasing. And in OpenObserve, we have a filter section that will show you exactly errors. If we are facing any errors, that you will be seeing them over here. So I will enable the errors only filter and run query. You will see there are no traces because right now there are no errors. It is working perfectly fine without any issues. Now let's go ahead and create some issues. So let's go ahead and remove shop and review. Remove that, and you will see the request coming in with errors, which means the transaction should fail. There you go. You'll see all these errors. And let's quickly open this specific trace ID. And if I go to trace timeline, this is how much each service is taking time to get a request and response. If I go to service map, you will see the service map is ending after product. Now, originally, if I go back and disable errors, run query, you will see the service map will clear all the way through. You'll see it'll go all the way to price because that's what we're actually expecting. Now, we'll go back and filter errors again, run query, and open this specific trace timeline once again and service map. You'll see it is ending at product. So when I go to product, the get request here, I'll go to exceptions. You'll see the exceptions that are recorded by OpenObserve by default. I can enable that, you can expand it, you can go over those, and also you can see the events that are happening as part of these exceptions. I minimize this one, you'll see all these errors. Now, what we can really do is now get back here and let's have price product review. Let's create some more havoc with these services. We'll remove these services. Let's have all the requests failing. and we should see a lot of traces coming in. Yeah, should see a lot of traces coming in. And if I open one of the full trace context here, and if I go to trace timeline, you'll see service map. You'll see the front end, as soon as the proxy is receiving the request, it is going all the way to price and also to review. And each span IDs, we have exceptions, we have attributes like we discussed. So you'll be able to correlate them, you'll be able to understand what is going on, and you can debug the issues in the service map. And now what we have done is I have built a dashboard. So let me quickly go to dashboard. This is the dashboard, the hot commerce dashboard. You can also download this one. And this, we are actually showing request per service. If you see, we have front-end service price, you'll see how much percent each request is being hit, right? For the product, we are getting about 26%, about 4,000 requests. And in the same way, how many errors were recorded? So I will refresh the dashboard once again. In the last 1 hour, we have about 160 errors in the front end and 225 in 57. And let's make it back to 15 minutes. And you'll see the request per service coming in a stack chart. And also, we do have a comparison analysis. So which means, for example, let's say the front end service 5 minutes ago, we have about eight requests. The front end right now, we have about 120. So you can actually correlate, drill down. You can do everything through dashboards for the traces when you start building them out. And I also have exceptions. We have built exceptions to see if I quickly go ahead and edit this panel, and you will be able to see how I'm filtering out. I'm getting all the services that are expected to be here. And then we are filtering out the services by error and the events. So we want to make sure there are no null values coming in. And you will be able to see the error messages on the left-hand side and all the events that are happening over here. Now, when I go back to my traces, now again, as part of this demo and only in this webinar, we are having new features that will be shown only in this demo, but are not currently available to our cloud or SaaS users yet. So I'll quickly go to service map. And in service map, this is our demo. And you can search for the services, but you can see the front end is getting about 11,000 requests right now with 270 errors. So we have about 2.36 error percent. So the service map helps you understand how your flow is. This way you understand if your transaction is making all the way from head to tail. We have different ways of having the service maps in OpenObserve. So one is, of course, the vertical, which is much easier. And then we have a radial. And also, let's quickly go and take a look at graph view. In the graph view, you can see, and again, like how each and every service is interdependent and how many the dependency services on each service, right? Like a dependency graph. And you will be able to see the number of requests, the number of connections, and the error percent again. And you can simply disable these metrics as well when you want to go and debug. And let's quickly run the query once again. And all the services. So the best thing about having auto instrumentation is you need to understand what services are actually making all the way through your database queries or your transactions without missing or without failing. Or if something is failing, you need to go ahead and quickly troubleshoot them. So this way you have much more visibility. You will be able to handle any errors. So you'll be able to quickly debug and correlate them with the logs and metrics when they are needed. Now, some of the challenges with auto instrumentation is you cannot have a correlation directly from traces to logs unless you quickly go and debug or you modify the code to your application. That's where you will be able to do a lookup from traces to logs. Yeah, that's pretty much about auto instrumentation and what we actually do. But feel free to ask any questions and I'll hand it over to Simran.
Yeah. Yeah, that was great, Chaitanya. Yeah, I'll quickly walk over through what we have covered today so that we can recap our learnings. So, we talked about how crucial tracing is for root cause analysis. Then, what are the ways to collect the tracing data, like manual instrumentation? What are the challenges with manual instrumentation? And then we covered how OpenTelemetry auto instrumentation helps to ease out the process for us. And then we took a look at how we collect the tracing data in OpenObserve and make use of the inbuilt features of OpenObserve to figure out the issues or the things going wrong with our system. So we have OpenObserve Cloud offering. Feel free to sign up for 14-day free trial, try out the demo, play around with the different features we have, and yeah, I'll wait for 1 minute or two so that everyone can go over OpenObserve website and do the cloud sign up. Yeah. Meanwhile, if you have any questions, feel free to drop it in the chat.
I think we have a question. Let's
Yeah.
see. How we expect where the actual error occurs in auto instrumentation rather than adding the instrumentation in code. In auto instrumentation, when we annotate each service, we will be expecting these errors to occur when a service goes down, right? Now, in manual instrumentation, yes, you can go deep diver. You can actually debug where you want to throw an error and where you want to propagate a trace. But in this scenario here, in Kubernetes or any Docker mode, when you're deploying services, if a service is unavailable or if a service is having connection timeout, then that's where your transaction starts failing, and you will be able to capture errors for that service level. So let's say in our scenario, we have a shop service depending on review service. So when a review service is unavailable or we have a timeout, then the shop service is expected to throw errors because that cannot reach it cannot reach the next service. So that's how we troubleshoot it.
Okay. Chaitanya, we have another question. Is OTel safe to use? What about the sensitive data in spans or attributes?
Yeah, OpenTelemetry is of course safe to use because it's a highly reliable, it's a good open source on the platform. And in especially if you think there are sensitive data or if you want to redact any sensitive data, then in OpenObserve we have an option to use VRL transformations. You can transform the data. We can use multiple VRL functions to redact the information, to encrypt it, or to even remove that sensitive data. And then you can send everything back to your stream in traces. So you can also, yes, you can also control how you want to store and how you want to encrypt your data through OpenObserve. But OTel is generally considered to be very safe. We have one more question. Is it possible to DB metrics or observability from the same? If I understand this question, I think the question is more about can we do the same auto instrumentation for database metrics and observability? The auto instrumentation is meant for traces alone completely. And so for the metrics, we should have, for example, let's say Prometheus or any node exporters running on your machines, or for example, in this case, Open Telemetry, we can take OTel contrib collector usage, right? We can have a source from any database, for example, MongoDB, Postgres, GraphDB, depending on the databases. We can use OTel collector contrib to have proper observability and all the metrics for the databases.
Okay, we have one more question, and that is we are afraid OTel will flood our backend with too much data. So, can we control sampling or reduce volume?
Yeah. So of course, so when you deploy hotel collector in clusters or anywhere, you have a batching option. You can batch them depending on how much batches you want to send. And you can also filter out them within OpenObserve itself. We have option in the pipelines where the pipelines can quickly help you filter out the data that is only needed. And the rest of the data, you can actually get rid of it. As a matter of fact, I can quickly share my screen and show you the pipelines and how it actually works. So that way anyone can filter the data and actually they can keep the only required data. So let me share my screen. And if I go to pipelines, click on this specific pipeline, you can see that the data coming in, for example, in this case, logs, this default. We are doing aggregations. We're also having conditions. We are scheduling some of the data. So, and finally, we are filtering out and doing transformation and then storing them in the same stream. So that way, your data is not flooded, your stream is not flooded. You have the right data coming in, and then you will be able to create alerts and the dashboards on top of the filtered data. Hope that makes sense. And
Yeah, we have one more question. Is there a way to see which service or function is contributing the most to latency?
yes, we can surely do that within the traces. I can quickly go back and share my screen once again. And in this way, if you see, we have ingested some data. On the right hand side, you'll see all the time it is taking for that specific transaction, right? Now, in this case, let's say I have opened, let's go back to trace and run query once again. Let's go to default and go to service name, and let's say front end run query. Let's open this specific transaction. And over here, you can see how much each of these in a query is taking, right? For example, the front end, the whole time it took is about 14 milliseconds. The same way within this, each of this span ID, I took 12 milliseconds, and the whole product, you can actually get it from the parent span ID, right? You'll say it took about 30 milliseconds. But yes, you will be able to see them and you will be able to filter out if a specific service is taking more than 2 seconds or maybe more than 5 seconds, then that will be your latency issue. For example, in this scenario, I'll say duration is more than 1,000 run query. Let's say last 1 hour run query. Let's throw one more zero run query. You'll see I'm trying to filter out all the data which is more than 1 second. So if you want to identify which transactions are taking more than 1 second, you can actually filter out using this. And if you want to do more than 3 seconds, you can surely do that. So in this case, I have some of these transactions because there are errors that are locked. We have some transactions taking about 3 seconds and some about like even 11 seconds. So yeah, this is how we can identify latency. You will be able to troubleshoot it and debug which service is causing that. Okay, I hope that answered the question.
Yeah. Okay. The another user have query that they are using Jaguar for collecting traces. Can they ingest it in OpenObserve?
What is it? Eager?
Jaguar for collecting traces, and can they ingest those traces into OpenObserve?
Yeah, so Agar is again, it's an interface, right? So when you ingest the data, you can use Agar as an interface. The same data source, if you're using OTel, if you're using any others, you can actually send the data back to OpenObserve. You can still have two interfaces, but using OpenObserve, you have much more advantage of controlling the data. For example, if you want to transform the data, you can strictly do it through VRL functions. Very simple and straightforward. So yeah, you can use the OpenObserve for that. Yes.
Okay, great. Yeah, that was the last question. Great. Thanks everyone for joining in. You can connect with us over Slack. You can reach out with any queries you have. We will be answering you there. And you can also connect with us over LinkedIn. And we have a good YouTube channel where we share good tutorial videos. So yeah, feel free to go ahead and watch those out.